we will go over question number 11 for summer 2023. This is Numeracy non-calculator exam. Let's read it together here. Safety Cones is a company that makes traffic cones. So these are the traffic cones here, as you can see. Its traffic cones have a base in the shape of octagonal prism. So this is the octagonal prism with a hollow cone shape sitting at the top of the base. So this one is the hollow one. The bases of the traffic cones are symmetrical, and if we look to here, it seems symmetrical. As you can see, the bases here are symmetrical. And traffic cones to be stacked. So it be stacked, what means it be stacked? If you look to this one, they are stacked together. There are some cones and they stacked inside each other. And then telling the dimension of the octagonal here, base are shown below. The height of this octagonal base is 5 centimeters. That's mean if we look here, it's 5 centimeter. This is the height or the depth of the octagonal base. And if we look, if we continue reading here, the cone that sits on the top of the octagonal base is shown below. So here is the cone. This one is the cone here. And telling you that it has height of 60 centimeter, which is this one is the height of 60 centimeter. And the base area of 800 centimeter square. It's not written here, and as we mentioned before, that all piece of information should be written in that diagram, so we can keep all information in front of our eyes. So I say here area equal 800 centimeter, and you know the area of this circular base equal by r square. That means we can say by r square equal 800, isn't it? Then we continue reading. Gray is transporting a stack of 10 of these traffic cones in the back of his van. So that means these are cones stacked together, and as you can see here, it's 10 of these traffic cones. So the number here are 10 cones. 10 cones. Calculate the volume of the space that this is stacked through of 10 traffic cones. So they're asking for the volume of all these things here. Given your answer in centimeter cube, which is expected because this is a volume. So while we are looking for the volume here, what we should do, how to calculate the volume of everything. Again, we have to split things together. This is one base, so that means if I got the volume of one base here, this one, volume of one base, then you can multiply by 10 to get the whole things here, isn't it? And then we can calculate the volume of the cone. Once you get the volume of the cone and the volume of whole 10 stacked together, we can calculate the total volume that's asking for. So how to start this one? We mentioned here that we have to calculate the volume of one base. How to calculate the volume of one base? You know very well that volume, any volume, equal area times height times depth times length. Call it here as length here, which here the length is 5 centimeters. So we have no problem with the height or the length of this base. So what we should do, we should look for the area of the base. Can we get this one? As also we talked together before, we said that it's important when we look to any shape like this, we split the shape to well-known geometries. How to split this to well-known geometries here? Can you see here? height through this line, you can easily find out that we have three shapes: this trapezium here, this trapezium, and the other one, the middle one, is rectangle, isn't it? So we should label it this A, for example, this B, both trapezium, and C is rectangle. It's important to label all shapes, so while you write your answer, the assessors understand what you are talking about. So how to get the area of these things? Let's start with area A, for example. You say area A equal area B. And you know the area A and B are trapezium, so area A equal A plus B divided by 2 times height. So this is a trapezium rule. What's A and what's B? We write A here and B there. It doesn't matter which one is A and which B. The most important thing is that both of them are two parallel lines, and then the distance between them is the height, as you can see here. And the height here, we could, if we have this distance here or this distance from here to there, we can get the height. And since they give us this is 50 centimeter here, and this one is 20 centimeter, so we can get this one and this one as both these sides are symmetrical. So this height, this distance is 15, this distance is 15. We can check this one by add 15 plus 20 plus 15, which will give you 50 centimeter. In this case, we can go to our writing here to see this is distance A, which is given, and then this is the other side, and this is the height which we found it now. If we used the trapezium equation here to get the area, A plus B divided by 2 times H, we can get the area of one trapezium here is 525 centimeter square. And if we add the two area of trapezium, it will give you this number here. So we have the area of trapezium A, area of trapezium B, which are similar. And if we can get the other area here, this one, which is the rectangle, then we add all of them together to get the total area of the base. And of course, you know how to get the area of rectangle. It's times its length times width here, get 20 times 50, it's 1000 centimeter square. And again, once we get the area here, it's very and quite easy to get the volume. How to get the volume here? Usually we have to say area times depth or height and length, as we stated before. So now we have the area. What is the depth? Depth is given as 5 centimeter. And then back to the volume of 10 bases. 10 bases here. So this is the area. This is the area of two trapezium. This is the area of one rectangle times the height. This gives you the volume. And times the number of how many stacked bases, which is 10, appears in the photo. This gives you the total volume for 10 bases of the cone. At this point here, we finish this part. As you can see, this part, the volume of one basis, this one, times by 10, so this one. So what's left here? This part, this one is left. So how to get this one? This is straightforward one. The volume of the cone here. Volume of the cone is given in the formula booklet, which is 1/3 by r squared h, as you can see here. We have no issues with the height. The height is given as 60. So what we think about it? We think about by r squared. By is a constant. R, can we get r? Yes, we have some piece of information we can get r out of it, which is this one here. So as you can see here, area equal by r square, and by r square equal 800. By rearranging you can get r, but remember this is non-calculator test, so it's not quite easy, straightforward process to get r without calculator. So, but there is another magic solution to solve this. How to this one? This is by r square, which is the area, equal 800 centimeter square. So remember, by r square equal 800. So look to the equation of the volume here. Can you see? It is the area of the circle, as you can see here, this one, by r square. So we don't need to rearrange or get the value of r. We just need to substitute by r square, which is equal 800. We just replace it by 800 here. In this case, it will be quite easy for and a straightforward process. It's 1/3 times 800 times 60 here to get the volume of the cone itself. So we have the volume of the cone, we have the volume of 10 bases. We add these together to get the value. Hope all of this are clear. If you have any questions, just contact me, and thank you very much. See you.